Hello everyone, welcome to my channel. I am Vivek Kaithwas, pursuing MTech in IT from IIPS International Institute of Professional Studies DAVV Indore. In today's video, we will be discussing about question end semester exam question paper of subject Introduction to Data Science and R Language. In this video, we have covered question number 1 to 5 and we will be covering question number 6 to 9 in next video. So please be stay tuned. And now let's start the video. First, it is the question paper, and first question is distinguish between hypothesis driven and data driven paradigms in data science. Provide an example of each. So, so it is the tabular format distinction. First, hypothesis driven. So, on basis of starting point begins with a predefined theory or assumption, and on basis of starting point, data driven paradigms begins with a raw data without prior assumption. And goal of hypothesis driven paradigms are to confirm or reject the hypothesis, and goal of data driven paradigms are to discover unknown patterns and insights. And process of hypothesis driven paradigms are form hypothesis, collect data, test statically, and process of data driven paradigms are collect data, apply AIML or generate patterns, then interpret. And data requirement for hypothesis driven are work even with small and structured data sets, and data requirement for data driven paradigms are require large and diverse data set. Tools used in hypothesis driven paradigms are statistical tests like t-test and ANOVA and regression, and tools used in data driven paradigms are machine learning models and clustering or deep learning. Outcome of hypothesis driven paradigms are validated hypothesis, and outcome of data driven paradigms are new current correlations, trends and predictions. Example of hypothesis driven: studying 2 hours daily improves the exam marks. Researchers collect marks performance, t-test draws conclusion. Data driven e-commerce platform uses ML to discover customers who buy headphones also buy power banks. Next, question number first B part, differentiate between structured, unstructured, quantitative, categorical data with suitable real world example. So here we have columns, types of data, description, characteristics, and real world example. For structure, uh, structures are data stored in tables with rows and column. And characteristics of structure is highly organized, easy to query. Real world example like bank customer database, student records, and unstructured data without a fixed format. And characteristics of unstructured are difficult to process directly. And real world examples are videos, images, WhatsApp chats, etc. And quantitative descriptions are numeric measurable data, and characteristics is supports mathematical calculations, and real world examples are temperature, age, marks, and categorical data. Descriptive labels representing groups cannot apply numeric operations like gender, blood group, product category, etc. Now, additional explanation: structured is best for SQL based analysis, unstructured requires NLP, computer vision, quantitative can be continuous, height, or discrete number of children. Categorical can be nominal, colors, or ordinal rankings. Now, question number two, write an algorithm that uses bias theorem for decision making. So, algorithm for bias decision making is first, step one, define the problem and identify all possible classes C1, C2 to Cn. Then step 2, compute prior probabilities, that is PCI, based on historical data. Then step 3, for the new evidence X, compute the likelihood P of X and Ci, and compute marginal probability Px equals to sum of Px Ci into Pci. Then step 5, apply bias theorem for each class. Posterior PCIX equals to PXCI into PCI upon PX. Step 6. Compare posterior probabilities of all classes. Step 7. Select the class with height PCIX. Step 8. Make decision and return the class label. Use case example. Classify whether an email is spam or not. based on the word frequency like free, price, and offer. Question number 2b. Write a suitable algorithm for association rule mining that can print all association rules, compute mean, median, mode, and standard deviation for given small data set. Explain when these are appropriate. Algorithms like step 1. Scan data set to generate frequent one item set with minimum support. And step 2. Use frequent k-1 item set to generate candidate k item sets. Now, step 3. Remove item sets with support less than threshold. Step 4. Repeat until no more frequent item set can be found. Step 5. For each frequent item set, generate association rule mining. Step 6. Compute confidence equals to support A union B upon support A. Step 7. Print rules with confidence and user defined levels. Question number third A part. Compute mean, median, mode, and standard deviation for given small data set. Explain when these are appropriate. So for computing mean, median, mode, first we have to take a small data set of exam marks. Suppose it as an example like exam marks 40, 50, 50, 60, 90. Now mean of these are formula for n values is x1, x2, xn. So mean equals to summation to xi upon n. So for the dataset mean 40 plus 50 plus 50 plus 60 plus 90 divided by 5. So 290 divided by 5 equals to 58. When appropriate, best for symmetric numeric data without extreme outliers, used in many statistical procedures and for all performance like average marks or average income. Next, it is now to find median, mid value. Arrange data in ascending order and for odd n, median is middle value. Here median equals to 50. When appropriate, preferred when data is skewed or contains outliers. Example, salaries in a company gives a better central value when one or two extreme values would distort the mean. Mode. Most frequent value. The value occurring with the highest frequency. In the dataset, 50 appears twice, other appear once, so mode equals to 50. When appropriate, useful for categorical or discrete data such as most common blood group, favorite products, or most frequent grades. Helps identify typical category even when numerical operations are not meaningful. Now standard deviation. Standard deviation means spread of the data. So first compute mean, mu equals to 58. Then find deviation from mean. So 40 minus 50 equals to minus 18 and 50 minus 58 equals to minus 8. 50 minus 58 equals to minus 8 and 60 minus 58 equals to 2 and 90 minus 58 equals to 32. Now square the deviations. So we got 324, 64, 64, 4 and 1024. So variance population equals to sum of all divided by 5. That is 1480 divided by 5 equals to 296. So standard deviation equals to under the root of the variance. So which approximately gives us 17.2. When appropriate indicates how tightly data points cluster around the mean. Small value means low variability used in risk analysis, quality control and comparing consistency of performances. For example, two students with the same mean marks but different grade. What is the difference between errors and artifacts in the data cleaning? Explain any two imputation techniques. So here we have aspects, errors in data and artifacts in data. So basic meaning of errors are incorrect values that do not represent reality. And basic meaning of artifacts are unwanted patterns or distortions introduced by collection or processing. Now typical causes of errors: typing mistakes, wrong units, misrecorded measurements, etc. And typical causes of artifacts are sensor malfunction, system glitches, pre-processing bugs. And examples of errors are age recorded as 250, negative salary, date is 32/13/2024, year month is 13, and here recorded age is 250, which is nearly impossible, and negative salary. Now, examples of artifacts are sudden spike in ECG signal and duplicate records after import. Effect on analysis in errors. leads to wrong statistics, wrong models, misleading conclusions. Now, effect on analysis in artifacts creates artificial trends or correlation that are not truly present. And treatment in cleaning in errors correct or remove incorrect values after verification. And treatment in cleaning in artifacts are detect source of artifact and filter smooth or remove affected data. Now, any two imputation techniques. So, first is mean median imputation. Replace missing numerical values by the mean or median of that attribute computed from non missing records. Mean is suitable for roughly symmetric data. Median is better when data is skewed or has outliers. Simple to implement and quick for small to medium datasets, but it can reduce natural variation because many records share the same imputed value. K nearest neighbors, KNN imputations. For a record with missing value, find K most similar record based on the other attributes using a distance measure. For a numerical attribute, impute the missing value as the average of that attribute in the K neighbors. For categorical, use the most frequent category among neighbors. This method preserves local structure of data and often gives more realistic value than simple mean. But it is compulsory but it is computationally more expensive and sensitive to the choice of distance metric and k. Next, question number 4. Explain any four common feature engineering techniques for continuous or categorical data. So, four common techniques are first is standardization, z-score scaling, converts data to mean 0 and SG equals to 1. Useful for algorithms sensitive to scale like KNN or SVM. One hot encoding converts categories into multiple binary columns. Machine learning models can handle categorical data. Binning or discretization converts continuous value into intervals and reduce noise and handles non-linear patterns. Log transformation reduce skewness in distribution useful for data with exponential growth, sales and population. Question number 4 B. What is sampling from a distribution? Describe inverse transform sampling or Monte Carlo sampling with an example. So, sampling from a distribution means generating values that follow a particular probability distribution, normal, exponential, etc., instead of random guesses. So, inverse transform sampling used when CDF fx is known. Steps generate uniform random number u which is the element of 0 and 1. Compute x equals to f minus 1 up u and x will follow the target distribution. Example, exponential distribution x equals to minus 1 upon lambda ln 1 minus u. Now, Monte Carlo sampling used when distribution is complex or unknown. Idea repeated random sampling used to estimate probability integrals or constants. Example estimate pi by randomly placing points in a square or checking how many fall in the inscribed circle. Question number 5. Distinguish between parametric versus non-parametric models and supervised versus unsupervised learning in with example. Parametric versus non-parametric. So on we have three columns: basis, parametric models, and non-parametric models. So on basis of parameter count, parametric models are fixed, and parametric count in non-parametric models grows with data. Now, flexibility of parametric models are low and non-parametric models are highly flexible. And parametric models data requirement are small and non-parametric models require large number of data. Now, parametric models training speed is very fast and non-parametric models speed is very slow. And examples of parametric models are linear regression, logistic regression, etc. And non-parametric models example are decision trees, KNN, random forest, etc. Supervised versus unsupervised learning. Supervised learning data types are labeled data types and unsupervised learning data types are unlabeled. And supervised learning predicts output and unsupervised learning discovers structures. Now, supervised learning outputs are classification or regression, and unsupervised learning outputs are clusters and patterns. Example of supervised learning are SVM, decision tree, naive bias, or example of unsupervised learning are K-means, PCA, etc. Now, question number fifth B. Define accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. So here we have a confusion matrix presentation of confusion matrix where there are two columns predicted positive and predicted negative, and two rows actual positive and actual negative. The first cell is true positive, then second false negative, and false positive and true negative. So definitions accurate for accuracy, how often the model accuracy is how often the model predicts correctly. So accuracy equals to TP plus TN plus T. Now question number fifth, define accuracy, precision, recall, and now question number fifth B, define. Now question number fifth part B, define accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. So here we have confusion matrix. Question number fifth B, define accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. So here we have a representation of a confusion matrix where there are two columns predicted positive, predicted negative, and two rows actual positive and actual negative. So for definition of accuracy, how accuracy is how often the model predicts correctly, and formula for accuracy is equals to and formula for accuracy equals to TP plus TN divided by TP plus TN plus FP plus FN. And for precision is out of predicted positives, how many are correct. So precision equals to TP upon TP plus FP. And recall, out of actual positives, how many model detected. So recall equals to TP upon Tp plus Fn, and F1 score is harmonic mean of precision and recall. So formula for F1 is F1 equals to 2 into precision into recall, and so formula for F1 score equals to F1 equals to 2 into precision into recall upon precision plus recall. Now, with an example, let Tp equals to 40 and Tn equals to 30 and Fp equals to 20, then Fn equals to 10. So, accuracy equals to 40 plus 30 upon 100 equals to 70%, precision equals to 40 upon 60 equals to 0.66%, and recall equals to 40 upon 50 equals to 0.80%, and 0.80, and f1 equals to 2 into 0.66 into 0.80 divided by 0.66 plus 0.80 equals to 0.72. Thank you for being in the video till last, and I hope this video would be helpful to you, and please like and subscribe to the channel, and please stay tuned for the next part of the exam paper series. Thank you.